Hi everybody, this is the work solutions and also something to put you to sleep, I'm sure, because you probably find it incredibly boring, but the work solutions of the non-calculator Compo from 2016. I hope you did quite well with this. So we'll start with A1. Determine algebraically if the following functions are odd, even or neither. Now highlight the important part. So it's this algebraically if they're odd, even or neither. We could also say the parity. I could call it the parity. It'd be very nice not to call it parity, but the back could call it the parity. So we'll start with A. I'm going to give myself lots of space. Notice it's only 2 marks. So remember, I need to put x to be negative x. So I've got 5 lots of minus x minus. Okay, so I've replaced x with negative x, which equal to minus 5x. Now minus x cubed is still minus x cubed, so it's like that. Okay, and now I'm going to make the plus. Okay, so, but is that the negative version? Well, we'll see. Well, if I take a negative out of everything, if I get a negative out of everything, I could write it something like this, which becomes minus, open brackets, 5x minus x cubed, and therefore f minus of x is equal to minus f of x, because this here is that there, and that, let's use, oh, actually I'll use green, oh, it's lovely green, is the same as that. So, and therefore we have an odd function. Part B. Let's try g of minus of x is there. Okay, so we have 3 minus x squared minus 4, which is equal to 3x squared, because minus and a minus makes it positive, and therefore we have f minus of x is equal to, sorry, it's actually not f this time, it's g, is equal to g of x, and therefore we have an even function. And I really want you to be writing the word therefore, even and odd. You have to do that. And finally, C, h minus of x is equal to minus of x. See how I use brackets every time when I'm doing my substitutions? And this is not equal to h of x, and it's also not equal to minus h of x, and therefore it's neither. We're looking for 2 marks for that, 2 marks for that, and 2 marks for that. A2. And remember, if I'm going too quickly, just pause it. You can slow it down. But take your time, make sure you fully understand this. This is stuff that comes up again and again and again in the back. And I know that you're in 6th year, you've got your 6th year trip to go on, all that fun. But the back's closer than you think it is. The pre-back's only a year away. Scary. Consider the function fx equals to x squared plus 2. Sketch showing key coordinate points. Well, you should know that this plus 2 is a translation and 2 units in the positive. Okay, so what I'm going to do. Now, I don't think I can make a straight line. Very well. So I'm going to put my axes in. Okay. Now let me put in red what the x squared graph is. So that's y is equal to x squared. So what we've done is we've translated it by 2 units in the positive y direction. So that there is at 2. Now make it a bit bigger, I'm sure you can do that. But I deliberately made this question nice and straightforward so you can get your 2 full marks. Sketch on the same pair of axes fx minus 2. Okay? Oh, that's a slight little mistake. Fx equals minus 2. Oh, okay. That's actually I'm going to have to give you a bit of credit for this question here. I was meant to write it like this. Now I'm going to be very, very generous to you on this one, okay? So what I'm going to do is it's meant to be a translation by 2 units in the positive x direction. I just had the bracket in the wrong place. The bracket should have gone there rather than there. I'm going to take this into account when I'm marking your paper, okay? It's meant to be on the same axis, so it's just meant to be, and we should have to minus 2, so it's going to be over here, okay? And this point here is going to be at 2, 2. Describe fully the translation of g of x, which is 2f of x, okay? And therefore we have a translation by 1 unit in the negative x direction enlargement by the scale factor of 2 parallel to the y-axis. That's it. Now I'm going to be very kind on on B, sorry. So that's worth 2, that's worth 3, but I'm going to be very kind with you on that one, and that one's worth 2. A3, consider the function 3x squared minus 4x minus 2, but first determine the coordinate point xy where the function has a gradient of 2. So I differentiate it. That's what I'm looking at. Then I'm going to allow the gradient to equal 2. So I'll allow that to equal 2. You could write that this has to equal 2, and I'm going to solve it. So add 4 to both sides. I get 6 is equal to 6x. Divide both by 6, so I get x is equal to 1. I substitute that back into f of x, so put that back into f of x. That is equal to 3 minus 4 minus 2, which is equal to 3 minus 4 is minus 1, minus 2 is minus 3, so the coordinate point is 1, minus 3. And you should be absolutely happy with that, and that's 5 very easy marks. So determine the coordinates of all the stationary points of the function f of x is equal to that. So I'm going to differentiate this. So I differentiate that. So that becomes 3 times a third. You don't need to have this bit, but I'm doing it just to help you out. Which is equal to this is the bit you should have. Okay. So I now need to let this equal to 0. So if 0 is equal to x squared plus x minus 2, I need to solve this, and I can do this by factorizing, so x is equal to minus 2 or x is equal to 1. So therefore I have f of minus 2 is equal to, beautiful this question, so I put in x, okay, so I have the third minus 2 cubed plus a half times minus 2 squared minus 2 times minus 2 minus 5, which is equal to minus 2 cubed is minus 8, so that's minus 8 over 3. Minus 2 squared is 4, so half of 4 is 2. Minus minus is plus, that's plus 4 minus 5. We just add a page. minus 8 over 3. 2 plus 4 is 6. 6 take away 5 is 1. So that's equal to minus 8, and it's just adding fractions, which is equal to minus 5 over 3. So we have that coordinate point is going to be minus 2 comma minus 5 over 3. If anybody complains about doing this, I'm only just doing fractions work with a bit of substitution in. And this one should be quite an easy one. Okay, so I have a third plus a half, minus 2 minus 5 is minus 7. Common denominator is 6. So it's 2 over 6 plus 3 over 6 minus 7 times 6 is 42. So 42 over 6 will be the same thing. So we have 5 take away 42 is minus 37 over 6. So I have 1 comma minus 37 over 6. Now I need to determine the nature of them, so I do a second derivative, or I can use a table of values. I really don't mind which you want to use. So it's 2x plus 1. I just differentiated the first derivative again. I put in the two values. Minus 4 plus 1 is minus 3, so it's less than 0, therefore it's a maxima, and put that in. I get 2 lots of 1 plus 1 is equal to 5. 2 times 1 is not 4. 2 times 1 is 2. It's 3. So it's greater than 0. Therefore, min. Okay. So we have minus 2 comma minus 2 comma minus 5 over 3 was a max, and 1 comma minus 37 over 6 is a min. And that was worth, well, yeah, there was quite a lot of work in there, but I have to have some challenging questions on there. A5, a sequence is generated by the recursive formula. By first generating the first 4 terms of the sequence, find the nth term rule for this arithmetic sequence. So I put U1 equals 12, U2 is equal to 12 plus 3, which is equal to 15, U3 is equal to 15 plus 3, which is equal to 18. So I'm just adding 3 every time. So it's 12, 15, 18, and 21, and I've generated the first 4 terms there. And next I have to just simply find the rule, the nth term rule for this. So I just got un is equal to now remember it's a plus n minus 1 times d. There are other ways of doing this. A is the first term, n minus 1, and the difference is 3 every time, which is equal to 12 plus 3n minus 3, so that's equal to 3n plus 9. And that was 6 marks. So if you can see, the previous question required a lot of working, that one required very little indeed. A6, the first 5 terms of the sequence are 7, 11, 15, 19, 23. Determine the 100th term of the sequence and the sum of the first 10 terms. So, is that the one that's, let's say 5, A6, okay. Difference is 4, so it's, the difference is 4 every time, so it's 4n plus 3. So, determine the 100th term, equal to 403. And the sum of the first 10 terms, sum of the first 10. So it's n over 2, 2a plus n minus 1, which is 10, minus 1 times d, which is 4. 5 times 14 plus 9 times 4 is 36, which is equal to 14 plus 36 is 50. 50 times 5 is 250. 5 times 5 is 25, and that's 5 marks. Yeah, I know I can work quicker than you, but I think you have enough time to do most of these questions, if not all of them. A geometric sequence is defined that generate the first 5 terms of the sequence, furthermore state if the sequence is diverging or converging. So, generate the first 5 terms. So, the first term, u1 is equal to 5, u2 is equal to 5 times 2 to the power of 1 is 10. Can you see it's just doubling? It's equal to 20, u4 is equal to 40, and u5 is equal to 80, and it is diverging. And that was 6 marks. So there's some very easy questions in here, but there was also some very difficult ones as well. I hope you find that useful.